This is January 07 A21 Module 4, and this is question 3. A pot on a potter's wheel completes 8 revolutions in 4.5 seconds. Calculate the angular velocity of the wheel. So we know omega is equal to 2 pi f, and f is 8 revolutions in 4.5 seconds. So therefore omega is equal to 2 pi times 8 over 4.5. And that gives you an answer of 11.17 radians per second. Part 2, calculate the difference between the linear velocity of a point on the wheel 5 centimetres from the centre and one at 15 centimetres from the centre. So at 5 centimetres from the centre, V is equal to r omega, and that is 0.05 metres times 11.17, and that gives you 0.56. 15 centimetres from the centre, V is equal to r omega, and that's equal to 0.15 times 11.17, and that's equal to 1.67. So the difference in those two, when you take them away, is 1.12 ms to the minus 1. B part 1, a lump of clay is placed on a potter's wheel, a distance r from the centre of the wheel. Right, I'll go the other way. On figure 3.1, sketch a graph showing how the centripetal acceleration of the clay changes as r increases from 0. So we know already that the angular velocity is constant, and this isn't dissimilar to a question a couple of years ago, where you know that A then is equal to omega squared r. Now you also know A is equal to V squared over r, but V isn't constant, as you've worked out in this question above. And so we're using this equation, A is proportional to r, and therefore that's going to be a straight line which goes through the origin. And it doesn't really matter what gradient it has. At what value of r is the centripetal acceleration 19 metres seconds to the minus 2? So A is equal to r omega squared. 19 is equal to r times 11.17 squared. And when you rearrange that, r comes out to be 0.152 metres, or we're asked for answer in centimetres, so it's 15.2 centimetres. Part C, a lump of clay of mass 0.2 kilograms is placed 10 centimetres away from the centre of the wheel, and the speed of the wheel is increased gradually from rest. The maximum frictional force between the clay and the wheel is 4.2 newtons. Calculate the angular velocity of the wheel just as the clay begins to slip. So we're talking about, this is the maximum centripetal force that can be provided. And so we want to calculate the angular velocity when we have a centripetal force of 4.2. So we're using mr omega squared, f is 4.2, m is 0.2, radius is 0.1, and omega squared we don't know. And when you do that calculation, omega comes out to be 14.5 radian seconds to the minus 1.